Yeah, so I can start with our updates. There's not much from us from Etherspot side. We're continuing to work on the changes to specs, and also we're looking to implement this simple whitelist alt mempool that was proposed by then for creating new mempools. I guess that's all from us.
With regards to that, Yov, Shahaf, is Dror going to be joining, or
yes.
do you guys have any updates on? I know you guys are focused mostly on the 0.7 entry point stuff. I did see some alt mempool stuff leaking into the 7562. But is there any work being done towards like defining that new schema? It sounds like Etherspot's working on the super old one that I know had a lot of comments from Yov and Dror about whether or not it's going to be what we'll want going forward.
Right. So there's no. We are not trying to define, and we're not going to define in the future as part of 4037 or 75 or 762. We're not going to define a schema for alt mempools. The only part you can see about alt mempools in the ERC itself is about how the reputation is managed, because this still protects the canonical mempool and also the alt mempools from each other, because so there are rules for throttling alt mempools that misbehave, so that it does not take down the entire bundler. But other than that, about schemas, I think they belong in separate ERCs. As we discussed before, there was the schema that you've been working on, and I know that there are others that people are talking about, but I think they are separate ERCs, don't you think?
Totally agree. Just wondering if it does make sense to start standardizing a few of these. I think like the one that I wrote is, at this point, I wrote it looks like in June. It's super outdated, and I stopped actually. We have it implemented in Runzler, but it's really lightly used. It's pretty much used just for a USDC mempool, which I think the new alt mempool, the new validation rules removed the need to for the particular USDC thing we were overriding.
Yeah, it's so there's a new rule. The new rule that lets a stake paymaster access read any storage pretty much solves the problems for the two problems in the USDC contract, both the implementation for the proxy and the POSD. The one thing that will still require an alt mempool that we still need to define is if we want to be able to deploy to pay during deployment and to create the initial allowance. This will require an alt mempool, and we'll still need to define that. But aside from this use case of deploying with USDC, I think the rest is covered.
Yeah. Mm-hmm. Okay. Well, I guess maybe after P2P mempool is up, it might make sense to start working on standardizing this format further. I know, like the definition that I have, I know you have a bunch of comments on it and reasons why we need to be a little bit more careful with the security definition. So yeah, it makes sense. Maybe we'll table that until after P2P.
Yeah, that's what I think we need to standardize it. We need to experiment. I wanted to first get 0.7 out and get to the peer-to-peer mempool. And then afterwards, but it actually becomes much easier to experiment because of the way we have a reputation for each alt mempool, which means that an alt mempool can cause a limited damage before it gets throttled. It will make it easier to experiment with different models, different definitions of alt mempools without putting everything else at risk. So that's the purpose of this reputation. Although you do have to keep in mind that it's okay to experiment with rules around storage, like alt maples that make certain things about storage possible, but you have to be much more careful when it comes to opcodes, because if you allow banned opcodes, any of the banned opcodes, it can be used to cause to detect on-chain execution versus bundle simulation, which means that the damage is no longer capped to just denial of service or the CPU. It can also cost gas for an entire for reverting a bundle, and this means that it leaks across the boundaries of across mempool boundaries, because it can drain the ETH for the bundler and prevent it from doing any work. So alt mempools should probably focus more on storage, less on opcodes, unless it's a very specific case that you verify to be safe.
Yeah, makes sense. In which, I think one of the recommendations of the past was to not even worry about whitelisting an opcode, just whitelist a function call entirely that uses the opcode in whatever weird way that you visually audited yourself as a bundler, and just say, hey, you could call this function selector on this contract and have no checks, no validation checks in that function call, because you've visually looked at it and hey, they're not doing anything weird with the gas opcode, for example.
Yeah, but even with that, you need to be very careful. I mean, we've seen several cases where people wanted to whitelist a function that seemed safe at first glance, and in all cases, we ended up finding ways that the function could be called by a malicious contract to detect on-chain execution somehow. Some of what it has to do with gas or with it. So you need to be really, really sure that the function does not leak information. Does not leak information in any side channels.
Yeah.
So in practice, it's not so easy to do it. It turns out.
Yeah. Okay. I can give an update on our side. We've mostly had to deprioritize our work on the P2P mempool for other internal work that we've been doing, but still pushing to get this last PR up. Jor had one more comment. He's not here, but I'll just speak to it real quick, then hopefully we can get this in. He had a comment on these two, which are seemingly weird little headers that we put in front of the message data as we try to create a libp2p message ID for the Gossip protocol. And it seems odd at first glance that there's even this concept of invalid snappy. And I also thought it was weird, and I looked into kind of why the consensus protocol, the consensus P2P protocol, would use this at all. And it turns out, at least in the Go implementation of libp2p, and I can't speak to other languages other than Go and Rust, but in the Go implementation, the message ID function needs to be it needs to be like a deterministic function of the message data, and it can't fail. So the reason why they have these two weird rules is because this function is ran kind of deep within the libp2p library on the raw message data itself. And so to make sure that there's no collisions, you need to do the snappy decompression, but snappy decompression on generic data can fail. So they had to define, okay, if this does fail, if someone does pass a bad message into the libp2p library, how should we assign? Oh, hey, Dror, I'll probably start over because you're here now. I was just explaining my comment back to you. Sorry, I didn't get to responding until like 10 hours ago, it looks like. So the reason why those two headers are there, the invalid snappy and the valid snappy headers, and this is speculation. I haven't actually talked to anyone who's implemented this on the consensus side, but looking at how Prism used it, this is my best guess, and I think it actually does make sense. The message ID function is this is for Go specifically. I don't know other languages. The message ID function is called from kind of deep within the libp2p library on the message data itself. And this is the post compression message data. This is the message data that you pass to the libp2p library. And that function can't fail. And it needs to be able to come up with like a deterministic and unique message ID based on the message data. And so they defined that calculation to solve two problems. One being that two uncompressed pieces of information can compress to the same value in a malicious way. Not that anyone would do that, but it's just trying to handle that. So they have to decompress in that function, and then that decompression can fail. So if that decompression fails, they use a particular header to make sure that they add that in front of the compressed data to make sure that that's distinguishing itself from uncompressed data that decompress correctly. It's all a way to handle, just to make it so that the message ID function never fails. Joe, you're muted.
Sounds far too complex for something that should be a way to define a unique ID.
Yeah.
It seems to me, I'm trying to think how they come, is that maybe they use it without compression and they had to add it in a way that is backward compatible to something, because I don't see any reason to encode the fact that it is failed. If you know that it is failed, there's one thing you can do with this message, and that is drop it.
Well, that's the problem, though.
No, don't encode the fact this is a failed message. Please drop it. You don't put it into the ID, because what do you mean failed? No,
I think I agree. I agree. However, I think the reason that it's there is because of the fact that where this message ID is getting calculated at least in the Go implementation of the libp2p protocol, there's no ability to drop it. It's already been sent to the protocol in this is the library. Like, we could go potentially change the library, but this message ID function is getting called after the user has compressed the data and sent it to the libp2p library, and the message ID gets calculated there in a way that function doesn't have the ability to return an error. So the only thing that the authors of Prism, for example, could do would be to panic or to crash the server. And I think what they decided to do was just use this invalid thing. This thing should never actually happen in a correctly functioning program. Like, they should never actually use that value. And if someone receives it, the peer, they'll just try to decompress it, and they'll fail in the decompression and drop the message on the peer side.
The reason it sounds funny to me is because the fact whether it's snappy failed or not, it's not that you pass a flag, do compress, or use uncompressed or use compressed. You don't pass a flag. So you can't calculate this ID, the meaning of this ID, without trying to decompress the message.
Mm-hmm.
So if you fail to decompress the message, I couldn't care less about this inner ID because it is failed. I don't want it. I don't want to define a protocol that enshrine failed something, because as part of the protocol, the only things to do with something that failed is not calculate what ID it has and flag and hash into this ID the fact that it failed.
Yeah,
you just drop it. So the only reason I can think you would do that is if you think there is some legitimate way, historical reason or whatever, to handle failed compressions.
Yeah. The issue is that there's just no way to handle, like, in the code, they have to call this
again
error.
If you say that, okay, the compression will fail on some messages and we need to handle that. If that is the case, you have to add a flag, compressed or uncompressed, to the message, so that the receiver side will know how to handle it. Not not hash it, this information. Hashing it is a way to obfuscate very deeply the fact that it failed. Like, I will try to decompress it. If I fail, I will create the hash one way. And if I will get the hash that you calculated, I know that both you and me fail the same way. But I don't care about failures. Don't send me failed messages. I will not try to decode failed messages. So to me, I'm reading it over. I read it then, I read it again, and it bothers me to add, because the library doesn't calculate the ID. It needs a unique identifier, right? It doesn't calculate the ID over the message. If it does, okay, calculate a compressed message, a raw message ID. Calculate it over the total hash of the entire compressed message, regardless of what's inside. If you need such unique identifier based on the content, we can do it. It's not something that we like to do, because we prefer to do the ID on the data regardless of the compression. I prefer to create that we create the ID. It is created based on the uncompressed data, and then this ID acts also as a way to validate that we use the exact same compression. Because if I get a compressed message, I decode it, and it doesn't match its ID, something is wrong. I have to drop it because it's a bad message. I will not encode this failure into the message.
I mean, I agree from a protocol standpoint.
Take whatever they did because they did it some time in the past, but
I think, again, it's an artifact of libp2p implementations in particular languages and how these message IDs get calculated. If you look at Lighthouse, for example, Lighthouse does exactly what you just said, where they calculate the message ID themselves on the uncompressed data. It can never fail. They don't even reference the invalid snappy header in their code base. Because
there is the only thing you can do with invalid snappy decode is drop, either as a sender or as a receiver. If you can't compress, drop. If you can't receive, drop.
Yeah.
If you want to be overprotective, take a message, try to compress, try to decompress. If it fails, your snappy library is broken. Drop the message and panic and say and open a GitHub issue because the library can't decompress what you just compressed.
Yeah, I mean, so I think the other solution for Go specifically, this is Go in a place where the message ID looks like it has to be calculated on the raw message data. So this is the compressed message data, would be to, if the decompression fails, to crash. And I don't know if we have any Go teams here, but my guess is that the consensus protocol went the route of there should be no way to ever crash. We'll still send the invalid message over and let the peers disconnect from us or whatever.
It looks like a hack someone added because they didn't know how to handle a bug in the compression. Because
well, how would you handle it?
I don't mind if the compressed data will contain a bit saying this message is not compressed. It is okay. That compressed data, sometimes the flag is sending raw, but this is part of the compression protocol. You know, there are layers here. There's transport, and there is compression, and then there is the message IDs and protocol above it. And adding the compression into the ID it sounds convoluted. It's obfuscating things needlessly.
So I guess the question is, like, what would we recommend to the Go teams who have to write a function on this compressed message in order to they have to create a function that calculates message ID on this compressed data?
Why do you see it? I need to look into the APIs and how it looks. I admit we are still halfway through the audit, and this is the next thing I want to do, but it's always the next thing I want to do. The way I see it in a protocol, you have a message, you have an ID for this message, it has to be unique. As far as I know, it doesn't have to be a hash at all, but It has to be a unique identifier in the system, and we want to calculate it somehow. And compression should be transparent to the application. Like the transport does compression. Okay, nice. Here is a message. Here's an ID, and I don't care about it. I don't want to see it as part of the protocol.
Yeah,
I need to look into the API to understand how. I don't mind putting it in and maybe remove it later, but it sounds like, I don't know.
Yeah, I would say my two opinions on it is, one, I think the consensus P2P team probably has a good reason for putting it in there. They're a pretty, sharp team, and they wouldn't put something in there just because someone was being neglectful. And I think the best reason I could find was looking into the Go implementation. So I'd recommend taking a look at the Prism implementation that I linked in my comment there.
I can't think of any better idea than some historical reason and backward compatibility for an old implementation. I don't think of anything better than that. It's a good reason to add such a feature.
Okay. Cool. Moving on from that, we'll discuss that in the PR. The other thing, not necessarily blocking this PR, but I did wanted to ask, and Parth is not here, but I'm curious if the Etherspot team can talk to this PR, is there's the canonical mempool PR that's open, and it looks like it's still blocked on the IPFS files, not actually being pinned. Do you have any updates on that?
Oh, I do not, but I will ask Barta. I will.
Okay. I'm probably gonna go forward if we on my gossip PR, which we want to link to that to the files. I'll probably just go forward without the link, assuming that if my PR gets approved before then, and then we can add the link in a subsequent PR. Cool. Do any other bundler teams want to update on P2P stuff?
Look, I'll manage your PR. I dislike this entire uncompressed, but it was there before. Yes, you modified it, but and shortened.
Oh yeah, that is true. I didn't modify. I didn't add that.
That was just rewrote it. So okay, we'll put it in.
Yeah.
But I do want to get rid of this. No, you did add these IDs here.
Yes. So what I added, the change, particularly the change in this PR was there was a modification to message ID to add the topic into the message ID, and this is also done in the consensus protocol as a way to be able to send the same message on multiple topics. And this is that conversation that we've had where if you try to send the same message ID on multiple topics, then the protocol itself, the libp2p protocol, will dedupe it. It won't let you send the same message ID twice, even across topics. So you have to have a unique message ID for your message that you want to send on multiple topics. A unique message ID for that per topic. So you have to throw the message ID, or you have to throw the topic name into the hash function.
The topic is the mempool ID, right?
The mempool ID, correct.
Which means we can't dedupe a message because we didn't want the mempool ID to be part of the message. Correct. So we are contradicting ourselves. We wanted a message ID to be based on the user operation, not on the mempool ID we send it on.
Correct.
But if you put the topic,
however,
message ID, you have to send it for each mempool separately.
Correct. However, if you don't, then you can only send it on one alt mempool because the protocol won't let you send it on more than one. And so we ended up going the route of saying, hey, we'll duplicate it on all the alt mempools as opposed to just sending on one. We felt that was the better angle to go then. Yeah.
So we go now with duplicating. Yes, it is will be duplicate for each alt mempool until we can tweak the protocol, the low-level P2P protocol to allow it.
Correct.
Yes. Okay.
Yeah, and that's the big change in the PR to the message ID. The invalid, valid, snappy stuff that was left over from the initial spec, which was copied directly from the consensus stuff. Cool.
So update for the Celius bundler. We are compatible with the peer-to-peer implementation from 1 month ago, but we are still waiting for all the PRs to be merged to adapt to the newest version.
Cool. I think my open PR is the last one.
The gossip, no?
Yep, the gossip one is the last one. There is this other one.
Okay, I'll mention now the gossip. Not because I like these snappy error messages, but because it didn't change in this PR.
Yeah.
Yeah, I had this PR about IBFS hash type.
Is that number 19?
Yes.
Okay.
It's about
I haven't looked at this one.
Yeah, it's about the IBFS hash type. It was defined as the bytes 32, but right now we are actually sending. I guess I have written the definition. Yeah. We are right now we are sending the ASCII encoding of the IBFS hash type. So it will be it will not be bytes 32. This is for the IBFS hash type. And also, yeah.
So you mean byte 46? Because we're using byte 46.
Yes. This is for the IBFS hash type. Also, for the bold user operation, bold user ops by hash response. It didn't have the response didn't include verified at block hash. So the receiving bundler, if these user operations failed verification, it will need the verified at block hash to decide if it will spam the peer that it received it from or not. Like to have the same workflow as a normal user operation received from another peer.
I agree with that. I'm looking at the PR now. One of my PRs added a container called verified user operation. So your PR doesn't need to have this pooled user op container. You can switch the response to being a list of verified user operations, and that will be correct. I agree with that change.
Yeah, but this bold user OB has a verified at block hash.
Yeah, I added a verified user operation container that has user operation, entry point, and verified at block hash on it. It's now in the main line. So you don't need a new container that has that. You could just have verified. The new container that we added, the verified user operation container.
Okay.
Okay. Also, you added a type called bytes 46.
Yeah, I meant.
There is no such type, and if you want to encode some information, then be explicit about it, because what is
Yeah, I did. Yeah, I did explain. I did. I audited the BR, and I explained that it is. 1 second. It is the ASCII encoding of the IPFS hash with the QM prefix.
Why is
It
that?
will. Right now, yeah, right now the bundlers are sending the ASCII encoding of the IPFS hash, not the 32 bytes encoding of the IPFS hash, including the
Yeah,
QM
we
prefix.
get
Yeah, because in
yeah
order
we
to.
get
Yeah, sure. Yeah, go ahead.
yeah sorry yeah so mempool ID is the IPFS hash, which is 46 bytes.
Yeah,
Wait,
yeah.
it's 46 bytes of the ASCII encoding is 46 bytes, or it's just like the IPFS hash value is 46 bytes?
Yeah, IPFS hash is 46 bytes.
No. It's the ASCII encoding of the IPFS hash of the IPFS bytes, including the QM prefix. It will be 46. But if we decoded the IPFS hash and remove the QM prefix to the, I guess, I believe it has to be transformed to base 58. It will be 32 bytes. Yeah, but we have to agree on which one we will use so that the bundlers can communicate with each other, because the IPFS hash is 32 bytes, I believe. But right now, we are sending and receiving the ASCII encoding of the IPFS hash.
Is there any reason not to use the 32 byte representation?
I tried to look about IPFS hash supports multiple hashing algorithms. So if we want to be generic and use whatever IPFS hash you use, then it should be a string. It's not 46 bytes. It's string to support whatever hashing mechanism you use. It has to be unique. If, on the other hand, we agree that we are using only SHA-256 encoding, which is 32 bytes, there is no need for prefixes, there's no need for specific encoding, then it is fixed on 32. So it's either fixed or dynamic. 46 is somewhere in the middle. It's use current encoding, we encode the prefix length, but we're not allowing anything else. So if you're not allowing anything else, why encode this prefix or this specific encoding?
Yeah, what I mean, yeah, we have to agree either side. It will be either be the ASCII, like the ASCII encoding, which will be 46 bytes. You know, I know it will be like doesn't have to be, but it will be for 60 bytes if it's ASCII encoding.
Because
yeah,
our protocol is binary. There is no reason to encode something in strings. If we use all string protocols, that would be fine, and then maybe we'll be use some encoding. But this is a binary field. Why do we encode text into it?
So okay, so the bundlers will need to remove the QM prefix and decode the.
You need to decode the hash. Get the hash out of this.
Yeah, because this is encoded as a base 58, so it will be. It will need to transform to
decode it back into a hash.
Yeah. Okay.
It's worth noting that your bundlers will have to go both ways potentially, because mempool IDs have the string version because they need a the topic has the topic string has mempool ID in it, and that's we've defined that as, it says the lowercase IPFS hash. So we probably need to define exactly what that lowercase IPFS hash is.
Wait a minute, mempool ID is string? Just a second.
Yeah. Sorry, topics are like mempool or gossip topics are strings. It's that slash. /account abstraction /mempool ID /name /encoding.
Okay. So no, we were doing here a mix of binary and text encodings. Okay, because if we are doing text encoding, it makes sense to leave IPFS hash as it is. This is the string. Now I'm trying to understand what is this array list. The other change in this commit. What is it? The status. Okay. So it's not a binary information that we are sending. We're sending a string information. Mempool ID has strings. So okay, so if we're using IPFS hash, so it's okay that mempool ID will be the full IPFS hash. But then when we return a list of supported mempools, it is not bytes 46. It's a list of strings. Maybe they have a max length of, I don't know, something, but not fixed on a. When I see something like byte 46 is a, I'm trying to understand what it is. It is a list of strings, and then there's a mempool ID. I'm trying to think whether we will have mempool ID that are not IPFS hashes. No, we do on the IPFS hash. Because if it's 46 compared to a text of, I don't know, 64, if it would be hex.
Okay, maybe we'll take this offline into that PR. I'm also noticing, I don't know where this went. Maybe I'm just missing it in the PR. I don't know. There's supposed to be part of the handshaking process where where bundlers send the mempools that they support to each other. That might have.
They don't send. I believe they're requested to.
Yeah, it's part of the. It should be part of the metadata, but it looks like the metadata is missing that definition inside of it. So, mempool. Okay. Yeah, it looks like the metadata definition for bundlers is missing the list of mempool IDs that they support. I thought that was in one of my PRs. I'll take a look at that offline.
Okay.
With our remaining time, I was just curious to hear about the 0.7 progress and where everything's going with that.
Okay. The other changes that are in the code and develop. Right now, we just started the audit, so there's no. We hope there will not be many structural changes to the entry point itself or the simulation contract. But in parallel, I try to start to do parallel work to move forward so that the reference bundler will be ready or almost ready, or by the time in the tests by the time the audit finishes. That will the final touches, and then we'll be able to release it. Test for the new branch. Regarding, if you like, regarding upgradability between the different versions, the way I see it is that a bundler for 0.7 is a different bundler. There is no real connections. Like, I don't mind, and it would be very nice to have the same RPC endpoint for both, and then it will be either by version field or by looking in the user operation field themselves to decide whether it's this and that. But they're clearly two separate implementations. It is possible to create a single server that supports both, but logically, they're completely separate. There is no shared information. Even the reputation is not something that could be shared between them. So technically, I think I don't think that 0.6 will ever see a real production mempool. We'll start that once we have 0.7. But even going forward, if they're going to be, I don't think there will ever be such a big change. We hope that the changes will be minor. So in that case, upgradability is something that accounts will have to do, but bundlers don't. They support two different protocols, two different sets of reputation items, and separately. So I don't. It is possible to have a paymaster or an account that supports both, but it is not that it has a shared reputation. It's a complete code split, so it can behave completely different between the two versions. So there's nothing shared.
Yeah, given the scope of the changes, we're, at least in our code base, likely to have a stop support for 0.7 at one particular version, and then have a completely new major version that starts 0.7 support, just given that the user operation struct changed. There's just it would be pretty complicated. I mean, we could potentially look at doing it, but likely that's how it's going to work in our code base. I guess that question that I have is, how is this going to relate to rolling out the public mempool?
Okay. We hoped in the past that the public mempool will be ready with the 0.6 version. Apparently, we advanced a bit slower. So I think that the public... okay, technically, all the code we are doing, the changes is regarding the mempool will be reused for 0.7. So there is no dead-end work that is done right now. And but I don't think it will get into production with 0.6. So 0.6 will continue as it is today, like private mempools, if you will. And 0.7 we'll do real sharing in production of user operations in the mempool. Regarding codebase, the way we see it is they have a branch for 0.6. It's going to be freezed. Maybe it will get the bug fixes, but and continue all the development on the newer version. And in parallel, we'll start pushing accounts to use the new version and upgrade to 0.7. We will need the transition where both are available, either as the separate RPC endpoints or the same.
Yeah, we're planning on supporting both for a while, given that there's a lot of 0.6 accounts out there. But okay, couple questions on 0.7. One is just expected audit completion date, and two is the 7562 changes. I see that there's still kind of work going on, or at least there was recently like some more reputation rule changes. Did the spec tests reflect the entirety of 7562 yet? And what's the status on that?
We worked on finalizing 7556 for the audit, but we haven't, on the documentation side, the spec itself and the tests are not yet fully aligned with that. This is what we are doing right now. We're trying to move that forward.
And you asked about the date. So we don't have a hard commitment date, but it should be before mid-February. So it's only the audit. The audit already started. So it's until there will be time for fixes if needed, but this should hopefully all end before mid-February.
Okay. I found where the supported mempools thing fell away. It looks like I had a bad rebase of my chain ID PR, so I'll put up a new PR adding it back to the metadata, because we obviously need to tell everybody what our supported mempools are. So I will add that PR after this meeting. That is my bad.
The question, I remember that there was a discussion whether it's something we publish every time on the metadata, or the ping returns the metadata, or just a sequence number. Where is it?
Yeah, ping just returns the sequence number, and then if you see the sequence number change, then you ask for the metadata. So the metadata is really only gossips.
Okay.
An initial handshake, yeah.
So you always ask for it on the initial handshake to know the first version, and then you keep track based on that.
Yep, that's also copied from the consensus P2P pools mechanism for metadata. So timelines for everything, P2P stuff. There was some discussion of attempting to get it ready by ETH Denver. Given that
It's going to be a
sounds
stretch.
like we want, yeah, given that we have to do these 0.7 changes before we have a real public production mempool, it seems like a pretty big stretch. At least I could speak for ourselves. The 0.7 changes will take a while for us to get into our code base, given that Rust is a typed language, and it'll be pretty difficult to figure out how to plug this new user operation struct through the entirety of the code base. It might be a little bit of a project for us to prioritize at some point. So not exactly sure when we'll get to it, but I'm not sure how the other bundlers feel. But if we're
the way we see it is that there is a change of user operation struct, but I think one of the things we did in that is decouple the on-chain encoding, transaction encoding from the user operation. User operation now becomes an in-memory structure, more flexible. It is not right now. It isn't even described in the ERC. What is described is the packed version, which with normal transaction is analogous to the RLP encoding of a transaction, which applications don't care about. The only place application care about the RLP encoding is when they calculate the hash. But other than that, they're using the unpacked structure with all the fields. This is the same will be with user operation. Yes, there are some fields that are the same, but whenever it's possible, we decoded the separate fields, like all paymaster fields, which means that some fields are optional. Like all paymaster fields are optional. You can remove them from user operation. In the packed version, there has to be a paymaster and data. It can be empty, but it has to be there. Same for factory and data, which is right now it's called in the packed version init code.
Yeah. So what it means for the bundler, like for a Randall, for example, is that you don't need to care about it in most places in your code, because you can use the struct. You only need to encode it when hashing or when sending it to the chain. The rest of the time, you can use whatever representation you like. It can be unpacked. And another thing that this enables more easily is support for native account abstraction with the RIP that we published. Because once we abstract it this way, we have an on-chain implementation and like an on-chain representation and the bundler side representation. It also makes it easier to have the same code for both native and 43.7.
Makes sense. Is it the same? Just I haven't looked at the native one in a little bit. Is the user operation the same as the native transaction type, the off-chain version?
There are still some differences, but the goal is to get them as close as possible to each other. It's not on the. I mean, of course, the on-chain representation will be different because one is a transaction type, but off-chain, when you look at the fields, they're going to be largely the same, like largely equivalent fields.
Yeah, likely for Rundler. We didn't anticipate this when we wrote it initially, but we're going to need to kind of make our code abstract on top of the transaction type and assume that the transaction types have a set of properties that any kind of object can adhere to. So potentially the same code base can support native and 4337 structures.
Yeah, most likely it will be. I mean, we're trying to make it as similar as possible. So most likely you'll be able to reuse almost all of the code, including also the mempool. So it's going to be a mempool for transaction types, but since it will have exactly the same rules because the rules are defined in a separate ERC. It has the same rules. It has the same fields and everything. So the mempool is going to be mostly the same except for the struct of the transaction.
And eventually, we are not there yet, but eventually the transaction type 4 should be the same as user operation. There are a few gaps here, but we thought whether we will be able to hash all the things, but we understood that 0.7 was delayed too much. So we want to get it out with the major things, but it is almost there. The idea is that they will be the same. Like a different endpoint. You have a native endpoint against a contract endpoint. Something like that.
Sounds good. So do we have a new target now for P2P mempool?
No, that's a separate one. It's not a it's not the native does not replace 43.7 in any way. They
No,
are
sorry.
And
I agree. I was more talking about just going back to our previous conversation. Given that we think ETH Denver is a stretch, do we have a target for P2P mempool?
I don't know. I'm still optimistic about ETH Denver. I mean, at least a test net. I mean, I hope that we can have at least a test net with 0.7 supported. Do you think that's not realistic?
The issue is 0.7. How much time each bundler will have to support 0.7? I can't tell you because I haven't finished it yet. I'm still working on adding to the basic layer, to the utilities, to the SDK, and then continue to bundler and see where are the issues there. And then, okay, I will also have to migrate the tests to the new version, so I will be able to thoroughly test it. And so I'm not sure how much, just doing this, I'm not sure how much it will take to each bundler. I will see how much it takes us, and then we'll forward it to you and have a... Once we do that, I think the P2P will automatically work because it works for 0.6. So if we all align on 0.7, it will work on all these 0.7 bundlers. So the question is how much time it will take the porting, not the P2P. But yes, the P2P is now postponed because we have 0.7 to finish. If you have many people to work on them and they continue to work in parallel, great.
Yeah.
How many people are working on your bundle? Only you?
Yeah, it's me and one other person, and me like half time because I have 10 other things going on. So
Yeah.
maybe it might be a little tough for us for ETH Denver, but maybe some of the other bundler teams will have a chance. We'll see.
Because I wanted also to add the canonical gas estimations. It's also on the table, something we need to do, but it was a stretch to add it. Yes, it is like a validation function, but at least now simulation contracts do not affect the on-chain entry point. So
Yeah.
it could be the entry point simulation, and we can add a new simulate just for gas simulation, a different contract, and technically even each bundler can use different simulations code and use state override because it is not part of the entry point itself.
Yeah.
Yes. So if someone come up with a good canonical way of estimating all gas, we'll be glad to incorporate it into the core library, but we all use it.
Cool. One more thing before I've got to drop. We have a PR up against bundler spec tests. I'm gonna get us to revise it real quick to remove a couple of the things in there that we were able to get around. But one of the things, and we talked about this last time, that we can't get around is it doesn't make sense to assert on message contents because different bundlers might have different error messages unless we standardize them, but I don't think we should. I think we should just standardize error codes and maybe the data that's associated with that error code. So there's a few places where the bundler spec tests were asserting on message contents that at least broke with our bundler, so we changed a few of those. So I'll put the PR in the chat again.
I see it. But you removed a message and also at least one place changed the code.
Yeah. So I'm gonna get them to clean that up and make it very clear, like split the PRs up and make it very clear which changes are which, so it's easier for you guys to decipher.
Okay.
Awesome. Thanks everybody. I gotta drop.
Okay. Bye.
Bye.
Thank you. Bye.
Bye.